Okay, let's pick this video up with the second theorem. Actually, first, let me go back to this one. So when the two angles, or when one of your angles is created by the intersection of the chords in your circle, you're averaging the intercepted arcs. Okay, so we add them up and divide it by 2. The second one is what happens when the angle is on the outside. So there's 3 ways this can happen, but we're going to calculate the exterior angle the same. So I can have a secant line and a tangent create an outside angle. I can have 2 tangent lines create an outside angle, or I can have 2 secant lines create an outside angle. All right, so regardless of what creates that outside angle, it's all calculated the same way. So instead of adding the 2 arcs and dividing by 2, we're subtracting the 2 arcs. All right, so we're going to take, and I'm going to try to do color coding, like, I don't know if this is showing up very well on camera. So I want you to see angle 1. So I want you to see where, I guess, the intersection of the secant line and the tangent line is. So it creates this arc over here. So I like to think of this arc as the farthest away arc from angle 1. Then the other arc is formed by the 2 intersections. So I like to think of the farthest arc from your angle and the closest arc. And so if we read through this, it says that the measure of angle 1 is equal to 1/2 of the measure of arc BC, the red one, minus the measure of arc AB. So I'm going to say here, farthest minus closest. All right, and so when I think about this rule, that's what I go through. All right, so think about that on number 2. So number 2, I've got an arc over here, farthest arc. Here's the closest arc, okay? So my equation for the angle is equal to 1/2 of the farthest arc minus the closest. So the measure of arc PQR, looks like the Q didn't copy. That's supposed to be a Q. So PQR and then arc PR, all right? Farthest minus closest. Same idea here. You have an arc that's farthest away from your exterior angle. Okay, so I've got arc XY. I've got arc YZ. Measure of angle 3 is equal to 1/2 of the measure of XY, or I would say farthest arc, minus closest. Okay? Now keep in mind, like on the second one here, these 2 tangent points allow us to break it into 2 arcs. So the whole thing, remember, still equals 360 degrees. Well, I have part of that 360 and the other part. Now, I can't quite do that here because I've got a little bit of the circle up here and a little bit of down here. So sometimes that comes into play. Okay, so before we try an example, if your angles are interior, you're adding the 2 arcs and dividing by 2. If your angle is on the exterior, you're subtracting the 2 arcs and dividing by 2. Okay? All right, I think that last page has a couple examples. So if you want to try these on your own first, feel free to stop the video. Let me do the first one with you, and then I might have you try that second one. Okay, find the value of x. So x is on the exterior angle. So here's what I'm thinking. X is going to be equal to 1/2 of the farthest arc minus, I almost wrote smallest, closest. I don't even know if I spelled that right. I think I did. For some reason it looks funny. 1/2 of the farthest arc minus the closest. All right, so this arc is the farthest away from my angle. This arc is the closest. All right, and I have numbers on there. So I'm going to be able to do 1/2 of 115 minus 25. Okay, and then I just kind of work through that. All right, so I'm going to be able to take 1/2 of 115 minus 25 is 90, and then half of 90 is 45. Okay, so x is 45. All right, if you want to try that second one, you might pause it and try that on your own, and then when you come back, I'll start working it out. Try to refocus. I don't know what's going on here. All right. Okay, let's see if that helps. All right, farthest arc, closest. All right, so I didn't color code on that first one. Let me color code. All right, so the outside angle, 54 degrees, is equal to 1/2 of the farthest arc, 13x minus 6. I think I'm going to run out of paper here. Minus, now your closest arc has 2 pieces to your expression. So I'm going to have to, let me see if I can squeeze that in there. So I'm going to do parentheses, 5x plus 14. Okay, so I'm not only going to have to take away 5x, I'm going to have to take away 14. Okay, so that would read, I would have 54 equals 1/2. 13x minus 6 minus 5x minus 14. Okay, so now I can combine like terms. So 54 equals 1/2. So 13 minus 5 would be 8x. Negative 6 minus 14 is negative 20. Now, let me show you one way to solve this that sometimes is useful. I can certainly distribute half into my parentheses, but I want to remind you another way that might help you solve in certain cases is if I multiply both sides by the reciprocal, it'll get rid of that 1/2. So if I come through here and multiply by 2/1, then if I do 54 times 2, I get 108. That equals 8x minus 20. And so when I multiply 1/2 times 2, that just cancels out and I'm left with this. Okay, and then if I go to solve from here, if I added 20 to both sides, I would get 128 equals 8x. Divide by 8, so it looks like I get 16 for x. Now, you certainly can just distribute that 1/2 in there. Let me kind of do that over here. So if you distributed that 1/2, then we would end up having 54 equals 4x minus 10. We're still going to get 16. So if I added 10 to both sides, that would give me 64. And so there's your 16. Okay, but sometimes it's really useful to double both sides or get rid of that fraction. And I can do that when all I have on one side is a number, you know, being ready to be distributed in. Okay, so the three, just kind of a quick recap, 3 big ideas. First one, that the angle formed by a tangent and a chord is half the measure of its intercepted arc. Let me see, my pages are out of order here. And then if you have an interior angle formed by 2 chords, it's the average of the 2 intercepted arcs, so add them up, divide by 2. If your angle is an exterior angle, you're taking the farthest arc minus the closest and taking half of that. All right, that's it for this section.